asks us to use the second derivative to determine the intervals on which the function is concave up and concave down, and to find all of its inflection points. Have to use the second derivative for this, and so what I've shown here is the first derivative. I've taken the first derivative, and so that's using the power rule. Bring the 4 around front, so we have 4x cubed over 3. And we bring the 2 around front here, so we have 2 times -8, so that's -16x. Then, when we take the second derivative, we use the power rule again. 3 comes around front. That cancels with this 3 in the denominator. And so that term differentiates to 4x squared. And then the -16x, being a first degree term, just differentiates to its coefficient -16. So that's the second derivative, 4x squared minus 16. Now we want to find the partition numbers that'll give us the intervals that we want to assess for concavity. And so we set that second derivative equal to 0, 4x squared minus 16. And here I have factored out the 4, and I show that. But then I don't show how I got the x plus 2 times the x minus 2. Well, that's because when you factor a 4 out of 4x squared minus 16, you have x squared minus 4. That's the difference of two squares, and the difference of two squares always factors this way. And from this we can see that the zeros of our second derivative are -2 and +2. And so those are our two partition numbers, and they're marked here on the number line. And then with those partitions in mind, we want to choose values that we can evaluate the second derivative, not the function or the first derivative, but the second derivative, to find out whether it's positive or negative. Well, the most convenient value less than -2 is going to be -3, so we evaluate the second derivative at -3, and so that's we've got an x here, so we put a set of parentheses there, and inside those parentheses we put the -3. -3 squared is 9 times 4 is 36, and we subtract 13, and that gives us 20. Not 10 as it shows here, but it gives us 20. And but that's a positive value, and that means that the function is concave up from -infinity up to -2. Then, as we always hope to, we can choose 0 as one of our values, and because 0 is between -2 and 2, we can use it. We can evaluate the second derivative there, and of course that's easy. It's easy to see that just leaves -16 as the value of the second derivative at 0. Well, -16 is less than 0. It's negative, and so that means that the function is concave down on this entire interval. And so that's what I've got marked here is positive below -2, negative between -2 and +2, and we know that negative values mean downward concavity, positive values mean upward. And here in the last interval, another easy value to choose is 3. And it's going to be the same evaluation that we got when we evaluated the second derivative at -3. 3 squared is 9, times 4 is 36. 36 minus 16 is 20, which, as I said, is what it should have been here. But I have a typo there. But I'll leave that in because I'm tired of talking. All right, so there we go. Concave up on -infinity to 2, concave down on -2 to 2, and concave up from 2 to infinity. And finally, since the second derivative changes sign at -2 and at 2, and both -2 and 2 are in the domain of the function, both -2 and f of -2 and +2 and f of +2 are inflection points. Notice that I did not evaluate -2 or the function at -2 or +2. I'm going to just leave this as adequate, an adequate answer to the question. You don't need to make those evaluations. Now, question 8 is one of these questions where we are solving to find the number of price reductions or price increases, and we use those formulas that were provided on exam 2 and which will be provided to you for the final. Once again, though, we're only maximizing revenue, so we don't need to calculate profit. So all we need is the quantity and the price functions, which we multiply together to give revenue. Well, remember that to determine the quantity, we take the original quantity, and the story says that the bistro sells 100 of this sandwich, 100, and for every 50-cent reduction in price, and that's what this x is, the number of price reductions. Right here it says let x equal the number of 50-cent price reductions. And for every one of those, they'll sell 5 more sandwiches. So that's where this quantity function comes from, 100 plus 5x. Then for a price, since we are reducing the price, we will have a negative here. The price function is going to be the original price, which is $14, minus, because it's price reduction, 50 cents. That's the amount of the price reduction, times x, the quantity of price reductions. And those two functions, those two equations, are shown in on that formula sheet that I referred to. That was the last page of your second exam, but which will be provided as a handout for the final. And so we multiply the price times the quantity, or in this case I have the order price times quantity, and I guess that's what I just said, actually. Anyway, when we multiply that out, we come up with negative 2.5x squared plus 20x plus 1400. Now, to maximize that function, we take the first derivative, and using the power rule, 2 times negative 2.5 is negative 5, and this constant differentiates away, and the first degree linear term 20x just differentiates to 20, and so r prime, the revenue prime, is negative 5x plus 20, and we set that equal to 0 to find the x value that's going to maximize revenue. So we add 5x to both sides, divide both sides by 5, and we have x equals 4. So 4 is the number of price reductions that will maximize revenue.